All right, hey everyone. My name is Nathan. This is Brooke, and we're going to be giving you section 2, which is on databases and asynchronous programming. It is recording. So basically, an outline of what we're doing today. First of all, this will be a quick fix, something that I found that'll help everyone in the long term. And then we're going to define what exactly a database is and everything else on the site. So before we even get into that, we have some tokens. So these tokens, these lovely tokens here, are going to be given out for participation. I want to make this as interactive as possible, right? I'm asking questions, you're asking questions, you're answering questions. So for every good answer, good question that you ask, you get a token. And at the end, we'll record who has the most tokens that you get in the front. I personally like the avocado. Yeah. If no one takes it by week 8, I'm still in it. So no one better claim it. All right. And now moving on to the quick fix that I was talking about. So last week we created a front end app, right? And if you run yarn start in your front end, all works fine and everything's great. The one great thing about React is if you make a quick edit, it'll just refresh, right? And you'll see that edit. So unfortunately for us, that's not what happened. It's because since we're using Yarn as our package manager, it basically doesn't pull in a package called ESLint. And it's not going to be pulling that in because it's deprecated, aka no longer supported. So this happens in our package log, package.json. Who can guess how we're going to fix this error? Just any wild guesses? Yes. One is install ESLint. I have ESLint installed. I still get this error. Anyone else? No? Well, I did what all good coding, what programmers do. I look it up on Stack Overflow, and you remove it. End of story. Get rid of it. This is within package.json. For me, it's lines 20 through 25. You may have something different, but essentially it looks like this. It tells you ESLint config, and it says React app and React app just get rid of it. It'll solve all your problems. Everything will work. So yeah, get rid of it, and everything will function as properly. Okay. Any questions? Great. Yeah, question.
If we keep it in, but we still don't, if we didn't get the error in the first place,
then you're chilling. Yeah. Okay. All right. So now to the meat of this workshop. What is a database? Right. We talked last week about how we're using MongoDB as our database. What is a database? So for that, let's turn to a restaurant example. Let's say, for example, I have someone, I'm the chef. Let's say I have someone come to my restaurants and they want an order that needs 2 eggs, right? And then, so I say, okay, cool, great. You have that order that needs 2 eggs. I'm going to go to my fridge, take out the 2 eggs, make up your order. And then another customer comes in and says they want the same exact order. So I'm like, okay, cool. I'm going to go to my fridge, get the eggs, and then blah, 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 right? So what was actually getting passed around? The eggs, right? I had to go to the fridge, get the eggs, hook up the eggs, and then return the eggs to the customer. So in this case, the egg itself is the data, right? And then the question is obviously what's holding the data? In this case, my fridge, right? My fridge is holding all the eggs for me. I know exactly how many eggs are in there. I'm the only one who can operate and open the fridge, right? Because I'm the chef, obviously. So that's going to be our database. Tangentially, going into what like a formal definition of what a database is, it's essentially just a structured set of data. How we're holding our data, right? It can be a large bucket for all we care about. That is going to be our database. And a really key concept within databases is database persistence, which means that our data is going to be, correct. It's going to continue to exist even when changes are made, right? So for example, on Monday, I leave the store. I have 6 eggs left, right? On Tuesday, I better expect that if no one touched it, I still have 6 eggs, right? The fridge is not going to somehow burn all my eggs and get 0 left, right? I want to make sure that I still have 6 eggs. So that is the idea of data persistence. And we'll explore this later on when we implement our actual, databases further into our workshop. But any questions about what databases are as an overarching theme? Nice. Cool. And now I'll turn it over to Brooke to kind of explain how we're going to actually implement our databases using schemas.
All right, so schemas, first big step to implementing our database. Just to start us off, anyone know what a schema is? Anyone can give like a quick sentences explanation of what a schema is.
Your schema is essentially like what your what your parameters are, essentially if you have a title field, maybe a currency for whatever. Think of it in terms of an Excel spreadsheet, like going at different columns with competitors. Basically, the schema is defining what
That's a great metaphor. That's exactly the metaphor we're gonna use. That's exactly the metaphor we're gonna use. Think in terms of an Excel spreadsheet. Think of doing that. What you have in an Excel spreadsheet, you have these rows of items. And we're in a restaurant metaphor. So we have our inventory. I think this is something we print out and we put on fridge so we can keep track of our inventory. You have rows of items, and then you have columns of properties of each items. So you have a lettuce and a tomato, broccoli, and all of these have properties like the names, quantities, and price. These are all things you want to keep track of. Now, what a schema is to this table, it's essentially the header, this highlighted row of the table. It tells you the structure of your data, essentially. You know that you can look at it and see you have an item with quantity, price. It tells you the name of the data you have in every column. And things like quantity and price, they also tell you the type of data you have. You know that they're going to be numbers. That's how schemas are essentially. And quickly, some other types of data you might want to have in your schema, apart from stuff that's actually describing the inventory. You might also want metadata, which is just data about the data itself. So you might want to keep track of stuff like when did the inventory change? Like when did we start running out of lettuce, or when did we get a new batch? And also who made the update, so you can like hold them accountable if they were stealing. And okay, now that we know what schemas are, a little motivation on why we want to use them, or even like databases in general. Basically, just think of a restaurant without a schema, without that like printed spreadsheet that we had earlier. This is just going to be the inside of our freezer. And if you didn't have something keeping track of the inventory, what's going to happen is you would have an order placed. Someone would want lettuce, tomato, salad. And what you have to do is go in, look through every row, find the lettuce. You need 2 lettuce, you grab that. You need 10 tomatoes. I don't know how much tomatoes you need. You need 10 for the salad. And you have to look around, find them. If you find them, you're lucky. The second time someone orders, you're going to have to look through it again. You'll forget where they are. You have to look through every bit and grab the lettuce, realize you're out of tomatoes. It's very sad. It's all just a very big mess. So if you're running out of tomatoes, you want a schema. You want your data to be structured and easily retrievable. You want to be able to insert things easier. You want a schema, basically. And how do we implement a database? There are 2 main types. There's relational and there's non-relational databases. We're going to go over both of these. And yeah, let's start with relational databases. Oh, but before we do, does anyone have any questions about schemas, what they are, why we're using them? Good, everyone's on track. Okay, relational and non-relational databases. So first on relational databases. Oh, we can skip over this really quickly. Yeah, just to extend on what we had earlier with the tables, now you have an ID for each table, you can have multiple tables, and you don't have to know about primary keys and foreign keys. Just know that relational databases are going to somehow have multiple tables with say different types of items, and they're going to link together somehow. The actual thing is like for primary keys and foreign keys. You don't need to know that, but just know that they're going to build relationships between the tables. You can link them. That's why they're relational. It's magic. It happens. And the way we talk to relational databases is through SQL. So I know what SQL stands for.
Structured query language.
Amazing. That's what that is. Structured query language is, like the name implied, it's kind of like a new language. It's the way you talk to your relational database. You can tell it to insert stuff. You can tell it to select, update your inventories. It's a very great convenient way, especially if you're dealing with a large amount of data. It's great to have like these fixed commands that can just do things for you. But we're not going to go too deep into that right now. If you want to explore relational databases more deeply, we have a README on the GitHub. I think it's /UCLA ACM/hack curriculum. And you can find a README with lots more in-depth explanation as to all of this. We're not going to go deeply into that right now. Instead, we're going to talk about non-relational databases. Anyone have any questions about relational before that? Right, you don't need to know too much about relational, whatever. Non-relational databases. So think about, instead of a table or like tables that we had earlier, we're now keeping track of our inventory with sticky notes. These are sticky notes, and we have to keep them on our in front of our freezer. And you see that instead of one single table, what we now have is one sticky note for each individual item. And they're all marked by different colors. That's like unique identifiable colors for everything. You on them you still have the same field schema. You have the item name, the quantities, the price, but now they're individual sticky notes. And the way to think about this is that what non-relational databases store is, instead of tables, a series of key value pairs. And if you've never heard that word before, don't freak out. What key value pairs are essentially is that you have a key. In this case, the key is the color of the sticky notes. It's unique, it's the identifier of every one of these documents. And you have the value. Everything that's written on the sticky note is the value of that. Switching into non-relational database terminology, what a sticky note in our example is a document. That's it's a single document. And the whole thing altogether is called a collection. That's what our database stores. What we're going to use to write things to interact with our non-relational database is JSON. Some of you might have dealt with this before. You use it a lot to talk to APIs, use it for a lot of stuff. It's basically JavaScript object notation. You can talk to the name that it's a subset of JavaScript. Basically, everything you write in JSON is also functional JavaScript. You can see the little side by side here of the JavaScript code and how it is encrypted in JSON. Some characteristics to note. Every object, this is a JavaScript object, it's encoded in brackets. All of the field names are in quotation marks, so they're all strings. That's not there, but that's about to do something to that. Everything separated by commas. You have columns here. Remember when we talked about these documents being key value pairs? You have this ID. This little thing here is the key for this entire document, and everything else is the value. Something a little interesting thing is that you notice that everything in here is also saying key value pairs. But that's not that important. Okay. Before we talk about selecting, any questions about non-relational databases? Everything good? Are we good? Yes. Okay, yeah. Yeah, that's a great question. I know it's like hard to see, like they look really similar, the JavaScript and the JSON. It's because we talked about, a document, it's going to be a key value. What we want is for the value to be as simple as possible. So when we pass this JSON into our code, what we're going to do is we're going to enclose it in quotation marks so that this whole entire thing is passed in as a string. It's not like a whole complicated JavaScript object. It's all of its objectness. It's just a whole big string. And when you take it out, you can do something called JSON.parse so that it's an object again, and you can do all the object things you said. But you see how that makes it simple? Okay, so they're like stored. Yes. But
it's not use, so we can basically take JavaScript, what you have a JavaScript object, turn it to this one, and that makes it easier to send over the internet or send to other programs, even if it's sort of like this common to other programs.
Okay, any other questions? Okay, good. Choosing between relational and non-relational databases, just quickly the pros and cons, just the pros of each. Relational databases, the pros, they're very secure, and they have lots of integrity. This is something that has been developed for a long time. ACID compliance is something we're not really going into today, but it stands for, I think, atomic, deep endurance, I for integrity, C, whatever. It means that basically the relational database has, when you try to alter it, you have to follow a certain set of procedures. A change either goes through or it fails completely. If it fails, that failure is hidden from the user. Basically, lots of things to make it secure and relatively stable. So it's not that hard to change. It also stores relationships, like we saw. You can easily model relations between different types of tables. And it has these stored procedures like SQL to make it easier for us to communicate with the database, but it also makes it harder to learn for us. Non-relational databases, they're a lot more flexible. You can see it was kind of like the sticky notes metaphor. Relational databases, once you set your schema on, that's what you're following. Changing the schema can lead you to lose data. It's a lot of work. With non-relational database, you just have to write a new thing on your sticky note. You can add new parameters, take them out. It's a lot easier that way. It's a lot faster. Also, you can think about like accessing your data. You don't have to deal with all the complex relationships between different tables. You just reach in, go for the document you want, grab the data. They're more scalable. Also related to the fact that relational databases have these set schemas. Relational databases scale vertically. Non-relational databases can scale vertically and horizontally, which is basically just to say that you don't have to keep following the structure you've already built. You can just add a new sticky note everywhere, and they're a lot more scalable in that sense. Can anyone guess which one we're going to use for our project? If you want it to be faster, we don't need that much security. We got simple structures. Yes. Great choice. Yes, that's exactly what we're going to use. We're going to use a non-relational database, and we're going to use MongoDB Atlas. Why would MongoDB? Nathan's going to tell you a bit more about that right now. Also about Mongoose and how we talk to our database.
Sure. So why MongoDB, right? Oh, yay. Well, first of all, it's stored on the cloud. So that gives us access to cloud computing, aka we don't have a database sitting on our computer. Anyone can access this database as long as they're authorized to access it. As well as just name dropping Amazon AWS, Microsoft Azure, Google Cloud, all those big names, hooray. MongoDB partners with them and gives us a service called MongoDB Atlas. And that essentially gives us the opportunity and the ability to kind of create a database for free. So that's why we're using MongoDB. We're also going to use another tool to help us communicate with MongoDB, and that is Mongoose. Where's Mongoose? The animal. Next. No, I'm joking. It's a specialized library that helps us interact with the MongoDB database. In long terms, it is a JavaScript object data modeling library. What does that mean? Who knows? Who cares? It just provides us functions and implementations that makes it a lot easier for us to manage data. Think about it as a claw going into a vending machine. I'm not going to be the one stick my hand into a vending machine to get the like soda, right? I'm going to have a claw or some sort of mechanism to do that for me. I'm going to simply press a number, and then that mechanism is going to take care of it all for me. That's essentially what Mongoose is. What can this little animal help us do, right? First of all, it helps us define our schemas. Like Brooke has mentioned, just like the headers of the spreadsheet, we're able to define our schemas for us. And then it's also able to manipulate data, aka is able to add, remove, retrieve a lot of our data. And how do they do that? By providing us with multiple functions, such as find by ID, or find, or create. So these are all functions that we're going to explore later on, but this is just a good preface into what kind of functions, what kind of functionality Mongoose can help us with. Question? Model is one of your schemas. So in one of our examples, we're going to have posts as a schema. You replace model with posts, dot, find. If you do post.find, then that'll go through, the entire collection of posts and find all of them for you. Can I answer your question? Great. Any other questions? And the docs are here for your perusal, but just look up mongoose.js and you should be able to find it. Yeah. The Mongoose is going to appear many more times throughout these slides because I was like, hey, why not? Let's pop in some mongooses. I don't know. I don't know. All right. So now onto a topic that we all love, which is asynchronous programming. Sounds very, very scary. But to kind of break it down, Brooke is going to give a quick analogy, and then I'm going to go into what exactly asynchronous programming is and what it can do for us.
Okay, we're back in the restaurant, right? And we are a chef. We are the new chef. We're the ratatouille chef, and we're in the restaurant. Our task is to make ramen. And what we're gonna do is we're gonna split that up into 4 smaller tasks. How do you make ramen? First you gotta boil water. You gotta put the ramen into the water. You're gonna cut up vegetables because it's veggie ramen. And you're gonna put the veggies into the ramen. Those are your 4 steps. And what are we gonna do? We're new, right? And this is a careful process. What we're gonna do is we're gonna first do the water boiling. That's gonna take 20 seconds. Water boils really fast in our hypothetical restaurant. And we're gonna do each task in succession, add the ramen, cut up the veggies, and then add the veggies. We're gonna do these one by one. And that's gonna work. It's gonna work. You know, people are kind of gonna look maybe and they're gonna be like, maybe there's a better way to do that. And we're gonna be like, maybe there is. So we think through it and basically analyze the situation. What you're gonna realize is that some of these tasks are independent from each other. You don't need to wait for the water to finish boiling to start cutting up your vegetables. And that's going to save you time. And that's what asynchronous programming is. With async, what we're going to do is first we're going to start boiling the water, and then we're going to start cutting up the veggies as well. Then once we're done boiling the water, we can add the ramen, add the veggies. The total time taken is going to be reduced, and we're going to do the same amount of stuff. Okay? Async? Async. Yeah, we'll get into the details.
My bad, sorry. So asynchronous programming helps us make our app more efficient. Before I go any further, are there any questions on the analogy and kind of understanding synchronous versus asynchronous? Yeah. Sure. Yes, you can think of it in that way. As opposed to doing one thing one at a time. Gotta finish one task and then go on to the next task and go on to the next task. You can start multiple tasks at the same time and then wait for their completion and then do other tasks at the same time. So yes. Question?
I know in Scratch,
Yeah.
you have like you have a series of blocks, and then sometimes this first block is like when a button is clicked, or after a few around each second. Is it kind of similar to this model of asynchronous programming?
So yes, I believe so. So when with Scratch programming, right, there's multiple control, like the yellow ones, right? There's like multiple start points to your app, right? To your program, that is. So yeah, essentially it is kind of what that is. Yeah. Nice analogy. Anything else? Great. Okay, so now I move into why we need to use async in our app. Why do we need to even use asynchronous programming in our app, right? So like Brooke mentioned, it cuts down our ramen making time from 45 seconds to 28 seconds. Me as an avid college student, I know that saving of 17 seconds is going to help me so much in life, right? And I want to bring that to my app. How do we do that? So in terms of my app, I'm not going to be, cutting vegetables, boiling water. Instead, I'm going to be talking to a database. I'm going to be downloading images. I'm going to be reading files. I'm going to request data. All of that takes a lot of time, right? We don't want our poor little mongoose to fall asleep because we're just wasting our time waiting for one to start after another. So what we can do is we can do other things while we wait for these specific requests to be fulfilled, right? So for example, I can initiate talking to the database while I'm downloading an image at the same time, right? To save me time in general. These requests are going to be fulfilled with something called promises, which I'll get into right now. What is a promise? A pinky promise. Hooray. Not really. A pinky promise, a promise is a wrapper for an unknown value, aka it's a little empty box that will eventually get filled. Think about me, I'm the app, and then think about Satyan is the database. I go to him with a little empty box. I say, okay, give me some specific values. Here you go, right? I've given it to him. I'm gonna go do something else by myself. And then he's gonna give the box back to me. And when he does, there's gonna be something inside the box, aka the values that I requested, right? That little box is essentially the analogy of a promise. I've given something to him, expected him to fulfill that promise, and then gotten it back in the end. So, like I mentioned, we can resolve that promise by opening up the little box and saying, oh, what's the value that I got from my database? Any questions on what a promise is? Great. Nice. It's either I'm so good at explaining or everyone is lost, but that's okay. Okay. So now we're going to go into two main methods of how we actually implement and use asynchronous programming and promises in our app. So the first option is using .then. So we have a little promise here. This promise represents a little box, right? I'm not going to do anything with this promise until I've gotten it back. And the .then does that. It waits for this promise to be fulfilled. AKA it waits for Sachin to give me back my box, and then it'll execute anything else. So if I don't fulfill this promise, nothing in here is going to be. So let's say I have now a value that is inside the box. I've resolved it, I've opened it, I've seen a value. And let's say I just, for this, basic concept, I'm just going to console.log that value, aka spit out the value that I have. So this is one way that we can use asynchronous programming. I'm going to wait for my promise to get fulfilled before I console.log my value, right? It doesn't make sense for me to log my value before I get anything here, right? Does that kind of make sense to everyone? Yes. Oh, thumbs up. Nice, thanks. Okay. So this is one way, right? But what if I want to do something after I get this promise again, right? So I need to have a something nested with it. So okay, that's fine. I'm going to take a look at this value. I'm going to wait about 2,000 milliseconds by setting a timer. Sorry, I put 1,000. I'm going to put 1,000. Set a timer, wait 1,000 milliseconds, and then I'm going to do something else. Cool. And then I'm going to console.log something out, right? But what if after I console.log something after, I want to wait again and then do it again? So notice how there's this, and then there's this, and then you can imagine if I have something nested inside, I'm going to eventually come up with something that looks like this. And no one likes this, right? There's so many levels of nestedness. Like I stop at 2 for loops. So if you give me 3 for loops, I can't do anything else anymore. This is the exact same idea. No one likes this, right? So to save us in terms of syntax, right? There's option number 2. Before I move on, is there any questions on .then? Yeah, of course. I'll go through it again. So we have a promise, right? It's a little box. Cool. This code is not going to execute. The .then is not going to do anything until my promise is fulfilled, right? AKA I get a request back from something. Cool. .then basically tells me that. Yeah. So once I get that promise and once it's actually fulfilled, AKA, oh, I know I have some sort of value in here. I don't know what it is yet, but I know I have some sort of value. I can just go ahead and take that value out. And then all I'm going to do is console.log. Cool. So that's essentially what .then is doing. Now, the further examples that I'm going into is to show you some drawbacks of using it. Cool. And then console.log. So if you go to your terminal, right, in VS Code, it'll just print out whatever it is. So think of it, if you're kind of using like C++, right, an analogy is C out. Right? You can see out something into wherever you can see it. Does that kind of make sense? Cool. Another question? That's just a name. That's just the name of something. So like it's not a keyword at all. It's just an example. Yeah, but .then is a keyword. Value can be anything that you name it. Console.log is something that actually exists. Yes. Yeah. And there's multiple ways to unpack that value that is within that box. Was there another question? Yeah. Sure. Yeah. So essentially the arrow function, to my understanding, it literally just this value gets passed in and it basically comes to here. This also replaces, I believe, if anyone wants to jump in, essentially value is what's unpacked from promise, and then it goes into here and then outputs into value here. That is essentially my understanding of how it works. If there's more technical description.
Yeah, I think you're right.
Okay.
Basically, the thing about the arrow.
Yeah.
Another way of writing.
Yeah, so like the value of the argument, you can have multiple arguments, the arrow is pointing to actual code next to it.
It's not too important. I think one thing that about is this something is called anonymous because it doesn't happen in. But unlike what you probably see in people, especially explicitly defining names to a function, essentially inside of the parentheses, that is function in of itself, and you can never do it in the.
Yes, exactly. That is correct. If anyone heard him over here, this is an anonymous function, right? Which means we didn't give it a name. So it'll literally just execute this whenever. I mean, we can just pull out everything from here and give it a function name and call it here too, that also works. But this is just the way we've chosen to do this because it's anonymous. Yes. Promise is like that request that I'm sending to him to come back. Promise. Let me back up. You're asking for like a name of a function, right? The function is held between these parentheses. Cool. So what he's saying is that I didn't give this function a name. The console.log value is not of anything, right? So that's what he's saying. He's saying that essentially this function here, right, has no name. We're just gonna execute it whenever.
And I think the important thing to realize here is that dot then is one function that we're calling on premise, and then passing in a function to it as an argument, right? So it's called a high order passing in a function. There's two separate. Right.
Yeah, but the console.log has no name. Yeah, great questions. Yeah.
So this is could have been like on short then that within like string value and value for
Yep, precisely. Great. Also testing my knowledge. I like this. Cool. So yeah, we saw that this creates our pyramid of doom. No one likes this. Yeah, you're gonna make a mongoose very mad. I literally had to search up mongoose angry to get this photo. So I did my research. Okay, so well, there's another way, thank God. And what is that? We're gonna use async/await. It'll make us a lot happier. See, happy mongoose. Again, I searched up mongoose happy to get this. So we're gonna write asynchronous code that looks synchronous. AKA, we're gonna write it like any other person would recognize. So that previous dot then whatever, so many questions, right? No one understands what the heck is going on. But now we're going to write it in a way that is easier for us to understand. Also, I think it's a lot. Yeah, we're still using the idea of promises, just different syntax, different ways of writing. So again, we have our black box as a promise, right? Coolio. I'm going to define a value that is called promise. I'm going to define a value for value that's going to be assigned to whatever I'm promising. Right? Cool. But like I mentioned before, the promise will take time, right? It's not instant. I'll go to send a request. Question as great as it is, it's not instant. It takes time, right? So how do I do that? How do I make sure that I actually get that promise by using the await keyword? So I'm going to stick the word await in front of here. What this essentially means is when JavaScript executes this code, it's not going to go past this line and execute anything underneath it until this promise is fulfilled. That's what the await keyword means. Cool. So that is essentially cross value equals await promise. And I'm going to do the same thing with console log value. But the one key caveat that we need to all make sure of when we're using await is that they can only reside in asynchronous functions itself. What does that mean? That means I have to define a function. I'm going to call it f, but I have to mark it as async. What does that mean? I slap on async here, right? So async and await go hand in hand. If you await something, your function better be asynchronous. It will throw errors if you say, if this is not there, but you have an await, it will say, oh no, await must be used with an asynchronous function. So this method and the .then method have the same exact effect, essentially. But now you can think of it, okay, so if I wanted to essentially get value, console.log value, and then I wanted to wait again, I can just insert another line below that says, oh, const value 2 equals await promise 2, right? Without all the semicolons, parentheses, and syntax that I need to take care of. Cool. Any questions on using asynchronous and await? Yeah, question. So .that. So both of them cover the exact same thing. They do the exact same thing, right? It's just different methods, different implementations that you want to do it. .that does not require you to use async or await, right? It's just these two, when used, must be hand in hand, essentially. Question. Yes. Oh, so why did I choose the constant of the log here, right? I can do anything I want. This is just a quick example as to, okay, I have my value, I'm just gonna output it, right? I could have done math with the value. I could have called some other function. This is just a quick example of, okay, cool. I'm just gonna take my value, I'm gonna console the log. Yeah, and that idea is gonna be repeated when I do my demo too. I'm just gonna console log something and then you'll just see it output it. Cool. Yeah, question.
I'm not sure what it was, and we made it like 1,000 nodes.
Yeah.
So how can we do that with this student?
Yeah. You're just gonna add a regular. So like you can use set timeouts, right?
It's just like the whole thing of it.
Yes. Yeah. Yeah. Mhm. Yeah. So it's asynchronous in the sense that if you have multiple asynchronous functions, right? So for example, let's say this one is getting data from my device, right? And then I have another function that says like download an image in the same exact way, right? I just have two different processes going at the same time. They're gonna get stuck at the await, but once that promise is fulfilled, they're gonna make sense? Cool. Yep.
So like if we don't use this function, instead the problem is that we get like almost like infinite mess.
Mhm. Yeah. So if we go back to these slides here, right? Notice how I'm going to console log a value, and then after I'm going to wait and do something, and I'm going to console log something after, right? Let's say this depended on the value that I got, right? And then let's say I wanted to add something inside here that depended on this value, right? So now I have a dependency. This value depended on this value, depended on this value, right? So I needed to wait for this value to get this value, and I need to wait on this value to get this value, and so on and so forth, right? And notice how every single time I do that nesting, I introduce a new set, just the syntax, essentially. I just introduce new semicolons within everything, right? And if you do Alt-Shift-F to format automatically, it'll give you that pyramid of semicolons, which no one likes. And it's ugly, honestly, right? So that's the entire motivation. And that's honestly up to personal preference too. You can use .then, you can use async await. I think I personally will be alternating between back and one or the other when I go through my demo. But yeah, essentially it's just two options for you to kind of see. So this is side by side, right? But one caveat with using async and await is I must begin an async. Otherwise, you can just stop that. Okay, so asynchronous programming was a huge topic, very, very convoluted. But I hope I was able to kind of break it down. Are there any more questions at all about asynchronous programming? We'll get into a few examples as to actually how we use them. But yeah. Where's mine? Where's mine? Bro, that's not helping your case. Come late to my workshop, also without my pizza. Anyway, all right. So that was .then and async and awaits side by side. Okay, so we're going to look at a tangible example in the code that will most likely write this. So I've decided to define a function called getPosts, and I'm going to say that it's asynchronous. So again, I'm using the async await model here. I'm going to pass in no parameters to this arrow function, and I'm going to say define a new value called posts equals to await post.find. So this .find is provided by Mongoose, as we saw earlier, right? This essentially what this does, it goes through my posts collection and it gets all my posts loaded. After I've gotten all my posts, because it takes time, right? It's not instant. After I've gotten it, then I'm going to just console log. So this is an example of how we're going to actually put the async and await model into code. Does anyone have any questions on this slide? Cool. Okay. So now my favorite part, demo. All right. So what are we going to do today? When we left off last week, we had essentially created a database in our MongoDB. We've created a front end, and then we've created the boilerplate, aka the skeletons for our backend. Cool. So what are we actually going to do today? We're going to actually we're going to actually connect our database to our backend app. After we do that, we're going to create a post schema, and then we're going to create a new post. These last three, we're just basically modifying right? We're gonna add a new post, we're going to retrieve all the current posts, and then we're also going to modify a specific post, which we'll see how we're going to get into in a bit. Cool. All right. So first step, we need the brains of our application. We need the brains of our backend, right? So we're going to create a new file called server.js. I'm going to do that right now. Okay. But for in general, I'm just going to explain it before I do it. Is I'm going to within backend, I'm going to create a file called server.js. All this stuff is going to be in here. This essentially, this first line here basically tells me, okay, I'm going to be using the Mongoose library. Second line will get filled in later, which is my connection string, which I'll show you how to get. This fourth line is for MongoDB. It's MongoDB specific. Sorry, Mongoose specific. I'll show you how to get to that. And then the 6 through 14 is essentially where I'm going to connect to. Cool. So I'm going to go ahead and do all that right now. So I'm now in here. Also, if you notice, I changed my theme from last week because dark theme doesn't really work well for everyone in the back. So if you can't see, raise your hand. I'll change the theme. But I'm just going to go with the assumption that everyone can see this for now. Right. Those of you in the back, can you see this? Great. Is it too small? Lovely. Okay. More contrast? Okay. All right. Let's see. Let's see. They do. You can see I did my research today. I downloaded so many themes. That's not it. Where is it? We can do this one. This one?
Yeah, I think the other one is light blue on white.
Okay, cool. All right. So let me know if you cannot see this. But this is okay. Great. Thanks for all that feedback. What am I doing? Server.js. All right. Okay, so within backend, I'm going to create a new file called server.js. I'm going to create this within backend. I'm going to call server.js. Nice. So now server.js is here. Notice how it's within backend and not within backend. Cool. So I'm going to first require the Mongoose library. So Mongoose, I'm going to go back. I'm going to say const Mongoose equals require Mongoose. So const Mongoose require Mongoose. Notice how Mongoose is important. Cool. And then I'm going to say, I'm going to create a new value for my connection string, which I will populate in a bit. So I'm going to say my connection string equals something blank for now. I'll show you how to get to that in a bit. Cool. And then I'm going to say, okay, I want to attempt to connect. So I'm going to say mongoose dot connect. All right. So I need to pass in specific parameters. The parameters I need to pass in are, first of all, the connection string. Yes. It will require an import. So require is for exported module, right? Out. Don't have certain nodes, you have to do generally, for example, cool. All right. So notice the parameters they pass in. They pass in connection. I need to pass in some configurations for my connection, and then so I'm going to pass in mongoose.connect. I'm going to pass in connection, and then I'm also going to pass in. So these are just provided so that your database essentially doesn't break. I believe they are use new URL parser and use unified topology. So use new URL parser and use unified topology must be true. Yeah. Yes. Yeah. I'll get to that in a bit. It's gonna throw me something, and I'm gonna say, oh, cool, this is where you put it. Yeah. And then we're going to essentially use a .then here, right? .then, and then I'm just gonna console log the right information that I've connected to the database successfully. So the mongoose.connect returns a promise, right? And they're gonna use a .then to kind of console.log connect to GB. And I'm going to say, okay, I'm going to then go ahead and console.log. And then if it throws any errors, I will have another thing called .catch console.error. Semicolon. This is the connection, essentially. Any questions so far? Yeah.
So whenever that basically works.
Yes.
Then
Then we connect to DB. Yes, exactly. That makes sense, right? I'm not going to output connected to DB when I'm not connected to DB, right? Okay. Now back to that connection string I was talking about. We got to connect somewhere. Where do we get that? So if we go back to mongodb.com, we should already have a cluster here, right? So these are the steps to get that string that we need. We're going to click connect. Whoa, so cool. And we're going to get a connector application. So this is within MongoDB, is within the cluster you've already created. Again, connect and the connector application. And then you'll get this. This string is the one that you need. This is the one that you want. Very important. And I'm going to go ahead and copy it. Notice I want to point out one key thing there. Password, they're not going to give you a password, right? Password here, you need to input yourself. So for my user that James created last week, my username was demo and my password was 1234. Very secure. So yeah, I'm going to copy this. I'm going to move it into here where I just created this. I'm going to paste it. And I'm going to replace password with my password, which is 1234. Cool. Exactly. Please don't. All right. No, not enough time for you to copy that. Okay. So any questions on what we just did? We essentially just secure that connection to the database, and we're all set together. Yeah. Question? How do we? Sorry. So how do you get that connection? So okay. You want to go to your MongoDB. So MongoDB. I'm gonna close this. Right. We're gonna click connect. And we're going to click connector application, and then we're going to be prompted with this string, which you should copy and which you should use. Cool. Yeah. Oh. Yeah. Which is right here. Cool. Yeah. Question? Commit server.js, my version of server.js? Like my version or your version? Either. And commit it to GitHub. As is. Well, it would just console.log mongo connected GB. Oh. Okay, yeah, please don't do that. That will not be good. I mean, granted, this is just a demo app, right? We're not gonna, nothing sensitive is going in here. All our passwords is gonna be like 1 through 5 or 0 through 9. That's just the entirety of, yeah. Cool. Okay. So now that we actually have our, actually for that, you get 5 tokens taken away. Anyway, so now we're going to test our connection. We want to see connected to DB, right? That is what we want at the end of the day. So many of you possibly have used NPM or Yarn, and typically for me, I write Yarn start. Well, it doesn't work if you don't add a script that says, what am I going to do when I run Yarn start? So I need to actually add that script. What I'm actually doing is I'm running node on server.js. So I'm going to go ahead and add that script in package.json. So I'm going to open package.json. Go after here, add a comma, scripts. I'm going to name mine start. You can name yours whatever you want. But I'm actually going to run node server.js. So when I run yarn starts within my backend, then I'm going to get connected to DB, hopefully. So I'm going to say, all right, I'm going to CD into backend. Again, I'm going to change my directory into backend. That's entered. Now I'm within backend. And then I'm going to run yarn starts. Hopefully, I will have connected to DB. Where is my connected to DB? Oh, this was that error you were talking about. Mongoose.set script query into false. What I'm going to do, copy paste it. So I'm going to yoink this and paste it right into server.js, right over here. Cool. And then I'm going to do this, and I'm going to run yarn starts. Why is nothing printing out? All right, what is wrong? Mongoose dot connection, yarn starts. Am I missing something? Node server.js. Start. Oh. All right. So in this case, it connected. I did not connect actually, and it just threw me an error. At mongoose.connect, it failed. Let's see why. Let me pull this up. Let's see why. Promise callback, blah, 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 blah. Apology description. Oh, did I type something in wrong? So here it says reason, topology description. So I'm going to say, okay, I'm going to go look at what I typed in. Maybe I typed something in wrong. Use unified topology. Unified topology is true. Use new URL parser. That's exactly what I have. Use unified topology. I'm on Edge Road. Interesting. Anyway, okay. Well, let's see if there's any other reasons. Replica set no primary. Oh, I think I might know what's wrong. Give me 1 second.
I think you need to add,
yeah.
Yeah.
Good catch. Thank you. That was a really good catch. Yeah, you gotta start that one. Which one do you want? You get perfect. Lovely. Here you go, catch. Nice. Thank you for that. Yeah, I realized I never run this. I have not added the IP address where I'm at right now. Anyway, now it should. Let's go. Connected to DB. Hooray. Okay. Anyone have any questions so far as to what we just did and what we're doing? Yeah. I added an IP address of my current internet. So the thing is with MongoDB is it requires you to be on an added IP address so that you're not getting attacked from like San Francisco. And you also need to have the proper users. So what I did not do because the demo unfortunately was not run on my computer, I had to add my current IP address. And so that's why he got a Pikachu. Okay. Anything else? Nice. All right. Moving on. You should see connected to DB. Like right here. If it's working. Are you getting a slew of errors? Did you input your password correctly? Okay. Yeah, go ahead and try that. And then of course we can help you debug all this later as well. Yeah, question?
Okay, so I did gain this error called one of these servers.
I'm not sure what that is. AR and Alex. Cool. Yeah. So all this, I just pasted it into my connection variable that I have, because this connection variable is being passed into mongoose.connect. And so it's specifying exactly which database I'm going to. So now we have a connected database. Cool. Yeah. Okay. Yeah, sorry.
I don't think
Sorry, can you speak up a bit?
I don't want you.
Let's bring it back real quick. Yeah, we can take a few minutes, get everyone settled, and then we'll move on to creating a schema. Yes. Yeah. Oh, okay. Yeah, make sure you take out the brackets that surround password. You want to remove it completely. That might be also an error. Yeah. So, Did it work for you? Yes.
So. You kind of have to not make it.
Okay, so that was a good enough break. Feel free to stay afterwards. We'll help you debug all your problems as well. But I want to try and get through more of the content here. Okay. All right, I'm just gonna go. For a orange dice, can anyone tell me what kind of fields need to be in my post schema? I'm gonna create a schema called posts. Can someone tell me a few things that a post should have? Yes.
So, like a body.
Uh-huh. It needs a body. Yeah, it needs a time. Sure. Number of likes. Sure. We can have a title. Yeah, correct. So you got all four of them. Minus the title. You got all of them. I don't know how well. My bad. Sorry. Oopsie. Anyway. I was always a swimmer. Never claimed to be any sort of basketballer. Anyway. But yeah, that's exactly correct. In our post schema, we're gonna have content, user, number, and a timestamp. And so what's gonna happen is I'm going to go ahead and create all of this in a schema. The code is all here. So what we're gonna do is we're gonna actually just go ahead and create this new schema with content, user, number, and timestamp. The type of the content is gonna be a string, and I'm gonna say it's gonna be required. The type of the user is gonna be a string. I'm gonna say it's also required. The number is going to be number, obviously, and I'm going to say the default value is 0, right? No one, as much as we want to, wants to start with a million likes. You can code that in here if you like. And then lastly, timestamp is going to be a number as well. That's going to be my schema. And then I'm going to say at the very bottom, what this does is it calls another function from Mongoose called mongoose.model. Essentially, it encapsulates this entire post schema into a MongoDB model. And it provides the schema that we have. I named it post. And then in order for other files to take note of what this is, I'm going to export. So all this code is going in a new file. Under backend, I'm going to create a new folder called models. Within models, I'm creating a new file called posts.js. Cool. And then all that code that I just showed you is going to go straight into here. I'm going to cheat a little and pull up all of that code. Magic. You guys will have the lovely time of typing it all in, but I have the code here. So now we've created a post schema. Okay. So now that we've created a post schema, I'm going to go ahead and try and create a new post. And I'm going to add it to the database within server.js. What I'm going to do is I'm going to, first of all, import it. This is how within server.js. I'm going to import it. And I'm going to say, once again, this is going to be constant post equals to post. I'm going to say, give it some content, give it a user, and then I'm going to give it a timestamp. And I'm gonna save it. This is very important. You must save it. Otherwise, no changes will be reflected. So I'm just gonna go ahead and type all this stuff. If I go into server.js, after all my stuff, then that's where I can say const posts equals require dot slash models slash posts. All right, I have post. And then I'm gonna create a new post here. I'm gonna say const new post equals new post. And now I'm gonna pass in the content, the user, and the timestamp, right? Content, user, timestamp need to be passed in here. So I'm gonna say contents. My user, and then timestamp. And then I'm gonna say new post dot save. So what I've essentially done here is I've essentially created a new post and I've saved the collection. And so what I do is when I run yarn start, I should see this now reflected in my MongoDB. I'm just gonna make sure I have everything typed correctly so that I don't embarrass myself again. But everything looks good to me. So I'm gonna write yarn start. Connected to DB, it should have run all this code. Did it run correctly? I don't know, we'll find out. Let's see. If we go back to here, our MongoDB, and I say I'm gonna browse my collections, just to see. And look at that. You have now a document with content, some content, user date, none-like content material, and that is the time that it is now. Notice how it's populated. Importantly, a underscore ID, which is the unique object ID of every single one of my documents. So if I create another one, I'll have a unique object ID, create another one after that, another object ID, and so on and so forth. So that was just me creating a post. Your MongoDB, so if you go back to your, once you log in, right? You just, this is what you create, browse collection, and then you should be, you should get that. Cool. And then you should see that's, hooray, now I have a single document here. Cool. All right, so that was the meat of my demo. I'm going to go ahead and go and breeze through the rest real quick. So like I mentioned before, we can use something called .find. And what this does is it'll go ahead and go through and find all my posts for me. And for me, I'm just going to call along my right. Notice I'm using the .then here. I could have very easily put this in an async await function, as we mentioned before. But I'm not going to do that just for time's sake because I don't want to create a new function, make it a async and all. This is fine. I only need one level of math. And then this is my console output. This is from earlier, so it doesn't exactly reflect the most updated one that I have. And then I can use another method called find by ID and update values by necessary. So I'm going to say, okay, go do my post again. I'm going to find an ID. This I copied from my object ID that I have, right? And I'm going to say, okay, I'm going to now modify the content to some newer content. And I'm going to save it again. And it should work for me again. Which it does. Trust me, it does. Trust me, it does. And so those are kind of a few, essentially a few methods that we have. But the question is, how does this actually go into our app, right? No one cares if we can just create a same post over and over again. And so to answer that question, you have to come back next week. We're going to talk to you about servers and APIs. Thanks everyone for coming. Sorry for going over on time, but of course, if you would like to stay, and I am, more than happy to plug everything. So yeah, thanks everyone.